All right, answers to homework 2.1. There you go. Take a look, see how you did. And we'll go from there. Hi, Margaret. And then we'll start 2.2. We should be able to at least start and finish that today. If you didn't get a chance to work on this homework, make sure you do that. I want you to just mostly just understand how to do it. There's not really a whole lot of math that happens behind the scenes just yet. We'll get to that today, tomorrow, Wednesday, Thursday. We'll see what happens with this week. We've already had a couple more positive cases come through today. So possibility that we don't make it through the week based on the number of teachers that it takes to keep this place running. So we'll be flexible. We'll just, whatever happens, happens. I will still be here. I'll still be teaching from school. It'll just happen virtually. Okay. No set plan and schedule for that just yet, but we'll do the best we can with this last chapter, basically. Any questions about that? It's all pretty self-explanatory. It's exactly what we did in class. I know it just feels like forever ago because that was last Wednesday. So there it is. If you have any issues, just let me know. And again, I made up the numbers in front for part 3. Okay, these are the 1, 3, -1, -1,000, and 2 were just my choice. Had to be a minimum, had to be a minimum, had to be a maximum, had to be a maximum, had to be a minimum. So I just kind of chose the sign and didn't really care too much about the number other than that. So hopefully that went okay. And if you're good, I'm good. Good? I'm good. All right, cool. Let's do it. I'm going to.
When are we gonna get back to the test?
I gotta see if everybody at this point. Oh, don't look. But the pull-up grades. I don't think everybody's taken it, so I can tell you how you did, but I still have 1, 2. I did, yeah. So I mean, grades, if they're not already in there, should go in today. I might have put them in, but I don't know that I did. I still wanted to go back and I started to grade like quiz 1.6A and 1.6B, and I still have to do 1.6C. So for this test anyway. So physically, I can't hand them back to you until everybody's taken them. I still got 1, 2, 3 in this class from the other cohort, and like 1, 2, 3, 4, 5 in the other one. So just some people that have been on. They've been out of the state, so, and other issues that are coming up. So cool. Done. Sweet. All right. Let's do it. I'm gonna take this with me. Dum, dum, dum. Take us on the right way. Something to write on. Chapter 2, section 2 begins right now, and I'm gonna guess that this is probably new. This is probably new stuff. So definitely want to write this down so you have stuff to go look back at when the time comes. Cool. I'm gonna pull up Decimals on here so we can look at some graphs or some things. It's chapter 2, so quadratic for a little while here, probably through the end of the semester. We'll see how far we get. You turn off this light. It's a little bit easier. Yeah. Yes, actually, I've been taking them out today, so I am happy to share the love. What I would do, that's fine. I'm just gonna give you this. Should terrible things happen, because he has been known to just be so comfortable, with the person that's holding him, that he lets it fly. Yeah. So if you want to come get him, you can come get him, or I will bring. Let me just bring him to you. Hey, buddy. Hey, come here. Well, his nails are a little sharp. All right. And feel free to go give him some love too at any point. Right now is a good time to do it. He's a good boy. He won't bite or bother you. The only thing you could do is poop on you. It has been known to happen. So, all right, cool. So 2.1 was vertex 1. Done. You did it. That's all you need. Okay. 2.2 is just a little different. Okay. It's called standard form. And this is probably the one that you're going to see. This standard form is a little glary there. Sorry, people. Standard form 2.2. It's the one that most functions start. So I'm going to write a function down for you this year, next year, the year after that. It's probably going to start in what's called standard form. So you can't tell what the vertex is just by looking. We're going to have to figure that out. And that's what I'm going to show you today. But there is a couple of things that we can tell just by looking at it. Again, I'm not going to call it y equals. I'm going to give the function a name. I'm going to call it f of x. It doesn't matter what that letter is in front. Again, it's just function f. I just made it up. And what I'm going to do on this side, it's just like I did last time, right? This side over here will just kind of be the stuff in general, and then we'll actually start trying to see what this looks like. So nothing here, okay? But what I will tell you, leave a little space right after the equal sign. It's got to have an x squared in it, or it's not quadratic. Okay, if you have x to the third, x to the fourth, x to the 2.5 even, not quadratic. Okay, and if you don't have an x squared, it's definitely not quadratic. So, but it could have ones less than that. So put a plus, leave a little space. It could have like an x term in there too. As long as there's nothing above the 2, we're good. If there's stuff below it as well, no problem. Okay, and I could plus some number. I could put a number at the end, which is like x to the second, x to the first, x to the 0, so the x goes away. But there could be numbers here, here, and here. Just like we had the A, the H, and the K in standard form, numbers at the beginning of the alphabet that have some pretty specific meanings. Same thing here. We could have a coefficient in front of the x squared. I'm going to call that A as well. And if I was writing something in standard form and I changed it to vertex form, that A would still be that number in front. It would be the exact same number. Nothing about it would change, which is why we keep it. A in standard form and A in vertex form, they're the same thing. But the next two are different. Okay, there's a pretty good chance that H and K compared to these two numbers are going to be different. Okay, this is not like the x value of the vertex and the y value of the vertex, unless it happens to work out that way coincidentally. It's not, which is why I'm not going to use H and K. I'm just going to use B and C. A, B, and C. Okay, letters at the beginning of the alphabet for those numbers that we really just don't know yet, right? And we don't, like once we have a function, those won't change. A will be 1, and B will be 6, and C will be 3, or whatever it is. Okay? And what I want to try to figure out is what we can tell from looking at this and what we can't. Okay? So I'm just going to like make up a function. And I don't know, we'll see what happens. X squared plus 2x minus 4. That is so far away. X squared plus 2x minus 4. Just wear it around. Need like one of those like GoPro headsets, and you can really get like the first person. It's probably so nauseous getting it home to watch this. Okay. Take a look. Is there anything about those numbers that tell us anything about the function? And what I'll do is I'll put like a second one up there. We can try to compare them and see if what we think is happening is really happening? I don't know, 2x squared minus 3x plus 1. And I don't know, how about one more, like negative 2x squared, gotta be x squared, I don't know, like plus 5 minus 2. Oh, I probably put a 5x in there. There we go. There we go. So you got the red one, the blue one, and the green one. I don't know if that's too much. Try to keep track of. But try to look for like important details. And maybe a point along the way that matches a number that's already up there. I tell you what, it's not going to be the vertex. You cannot look at this and tell what the vertex is without doing a little work. Yeah, Margaret. For which one? So which negative 2 do you think that is? The first one or the last one? Well, let's see if that's still true for the one in blue. Look at the one in blue. Is the y-intercept positive 1? Looks like it, right? Yeah, nice. Is the y-intercept negative 4 for the red one? Absolutely. And you're right. That last number, whatever that last number is, will always be the y-intercept. This number right there, 0, c, is the y-intercept. Every time. Not a little bit of work you have to do at all. So nice. Whatever that number is at the end is always going to be your y-intercept. And why? Because look what x has to be. It's got to be 0. If I drop in 0 everywhere where there's an x, all these x terms disappear. And the only thing that's left is the y value. So the only thing that's left is negative 4, positive 1, negative 2. Good. That's a big one. And that's really the biggest new thing from here that we can definitely tell to be true, is that the c value, whatever that is, there's your y. Cool. Anything else that we can tell, like maybe what the shape of the graph is going to look like, or I don't know, is there anything else? Yeah, Johnny? Yeah. Right, and that's the same, and that's why we call it A, right? That A from vertex form is the same A in standard form. That's still that vertical stretch or compression, whatever, it's still the reflection, right? If A is positive, we're going up, right? If A is negative, we're going down. And that's the exact same thing from last time, which is nice, which is why we still keep calling it A. That is absolutely going to be the case. Okay. A tells us the orientation, for sure. And C is the y. Okay. And the only thing today that I wanted to teach you was how to find that vertex. Because if we can figure out the vertex, we can kind of write it backwards in vertex form and get there. And so this is the new thing. Okay. A is that, C is that. B by itself does nothing. B on its own is not enough for us to tell anything else. It doesn't tell us where the x-intercepts are, doesn't tell us where the vertex is, but it is part of that, okay? And so here's the part that's new. And there's not a whole lot of math happening in the background to get us to this shortcut, because that's what I'm going to give you. I'm going to give you a super easy shortcut on how to find the vertex, if it's written in standard form. The math behind it isn't super complex, but you really won't understand it now. If I tried to show you it, you will understand it in like a week when I show you how they came up with it. Okay, so I promise it's there, and I'm not just doing magic, but if you want to find the vertex, I'm just going to give you the shortcut, and maybe you'll believe me. It's a point, of course, right? And I'm writing this big so that you can see it, because this is where a little bit of work is going to happen, okay? And for me, I'm trusting the calculator to do this work, but I need to know what number to type into the calculator for it to give me the right answer, okay? There's an x part and a y part, okay? The x part is a fraction, okay? And I'm going to use some of those constants, the a, the b, the c. I'm going to use some of those to figure out the x value. And again, I could tell you where it comes from, but I think it would just confuse you more without the knowledge in the back. Okay. The x value of the vertex will always be negative b on top of this fraction. Now, that doesn't mean it's a negative number. It just means the opposite of whatever b is. Okay? So if b is 2, this is negative 2. If this is 5, this is negative 5. If this is negative 3, this is positive 3. Okay? Just switch the sign. Okay? On the bottom goes 2a, 2 times a. So take this number and double it. That's going to be your denominator. Okay, negative b over 2a. Promise. There's reasons why we know this is going to work. And you'll see it's going to work every single time. Okay, that's the x value. Negative b over 2a. Okay. And once we figure that out, okay, I'm going to take a number, switch the sign, divide it by 2 times some other number. How do you think, if they gave us some function, how do you think we could find the y value that goes with it if we know the x value? Right, like they're gonna say, okay, here's a function. F of x equals x squared plus 4x minus 1. And we're gonna find the vertex. We figure out what negative b over 2a is. Right, we just do it. Where do you think we could take that x value? What could we do with it to figure out the y value that goes with it if we already know the function? Plug it back in, right? And this is what it looks like, right? F of whatever, right? That's that notation that says, if you're in function f and I want to plug something back in, okay, here's my x value, then f of that x value is the y value that goes with it. So f of negative b over 2a, right? Just in other words, just plug it in. Plug it in to the function for x, and let's see what we get. Okay, negative b over 2a, plug it in. Not a whole lot of work that needs to be done. We just have to figure out what negative b over 2a is. So, before we do any of this stuff, let's just figure out, all right, what's a, what's b, and what's c. So if you can figure out what those are, then we can use it. Okay. A is the number in front. The number attached to x squared. So if I don't write that number, what's the invisible number that's right there? 1. Okay, right there, right in front is 1. B is the number attached to x. Whatever that number is out in front of x. What is that? 4. Good. All right, that number right there. And then what's C? What's the number at the end? Cool. Well, so what's the y-intercept? Before we even do the vertex, let's do the easy one. What's the y-intercept? Good. Perfect. No work to be shown. Boom, there it is. Circle it, done. There's my y-intercept. So I know that this graph is going to cut through the y-axis down at negative. But I also want to know where it turns, right? Maybe that's an important spot for me to think about. And so what I want to do, so here comes the work that goes with it. I want to figure out what negative b over 2a is. So I'm going to kind of just drop down, do a little bit of work, and then I'll go back to the top and I'll write my answer. Doesn't matter what order you do it in. But if b is 4, this just says, change the sign. Okay, negative b, okay, negative 4. And then on the bottom goes 2 times whatever a is. Well, a is 1. Okay, nice. So I get this negative 4 over 2 times 1 is 2. What is negative 4 divided by 2? Negative 2, right? Right. Negative divided by a positive is a negative number. And because 2 goes into 4 evenly twice, I don't even end up with a fraction when I'm done, and that's great, right? If we can avoid fractions, awesome. Sometimes we need them because we're just stuck in between. Right? Some of these graphs didn't necessarily have a perfect, nice whole number as a vertex. Right? There's that one, 0.75, whatever. You know, and this one up here, the green one, 1.25. Not always going to fall perfectly at nice numbers, but sometimes it is. And there it is. There's the x value, -2 for sure. How do we find the y value that goes with it? Plug it in. You've got a function. Let's use it. This whole thing, remember, this is y equals. I'm just calling it f of x. I can tell it apart from other functions. But what I can do is if you give me a function like f of x, I can plug in any x value that I want, and I'll get the y value that goes with it. And since the one that we want is -2, I'm going to drop that in. See, look, f of x, f of -2. My x here changed to a -2, which means wherever I see an x, in goes -2. And standard form is going to have at least one x in there because it's got to have x squared, but could have 2, right? Because b could be 0, sure. But if it's not, then we have both values, okay? So -2 goes right there, -2 goes right there. And we'll see what we get. And for me, most of this is really just going to be calculator helping to make sure my arithmetic goes well. So we'll do it by hand since we're up here. -2 times itself. -2 squared. 4. Negative number times itself is going to be positive. 2 times 2 is 4. Okay. Sign in front is what I want to keep track of. So +4 times -2. Signs are different. Signs are different. Negative. Yeah. Yeah. And then -1. So I did exponents first, then multiplication. Just happened to be from left to right. So that's the way it's going to be in standard form, which is nice. So I did this one, then this one. Now I can just put these all together. 4 minus 8. So start at 4, subtract 8. And then subtract one more. Go even further. -5. And so if f of -2 equals -5, that means the y value that goes with -2 is -5. And if we did this right, the graph should back this up. X squared, was it +4x minus 1? There's that y value, right? Y-intercept, -1, just like you thought. Here's the vertex, -2, -5. Okay? And it works every single time. This stuff just works. Let's do another. GVEX, we'll make it a little trickier though. Let's go, I don't know, 2x squared minus 8x. I want to pick a nice one. Because that's going to be over there, so I want to put this one over here. Let's put it at like +5. Let's see if that's enough for me. And I'm telling you what, you're going to need A, B, and C moving forward too. So I always kind of like to write down A, B, and C. But first question. Sure. I'm going to go through the process of saying like A equals, B equals, and C equals, and just kind of seeing what I've got. So I can keep track of the numbers, and you're going to see as we build like past 2.3, section 2.3, we're going to need A, B, and C to do other stuff too. So I like to write them down. So what's A? What's that number out in front? Cool. To B, -8, and C. Cool. Whatever those numbers are, right? Just having them written down somewhere. It might just be nice to pull them out. It's not that A is 2x squared. It's just the 2, or it's just the number. Okay. All right. Let's start with the easy one. Where's the y-intercept? Right there. Right. C every time. And if you want to write it as a point like 0, 5, that's cool. If you just say 5, that's fine too, because you called it a y-intercept. I know you're on the y-axis, so I know what x has got to be. Love it. The real tricky part here in this section is just kind of figuring out what the vertex is. Okay, I know it's going to be a point. But I got to figure out what the x is, and then I'll plug it back in to figure out the y value. Our shortcut will always be negative b over 2a. That's really the only thing you have to remember moving forward. Negative b over 2a, negative b over 2a. And you'll see where that comes from. Okay, so if b is negative 8, what's negative b? Switch the sign. Good. Positive 8. So if it starts positive, make it negative. If it's negative, make it positive. So the opposite of b is really a better way to read that out loud. And then 2 times whatever a is. Well, a is 2, okay. So we get 8 divided by 4, which is 2. Nice. So that's a good number. It's a good start. So I know, and there it is, that's my xi. Okay. How do we find the y value that goes with it? I know what x is. It's 2. I know for sure. There it is. 2, supposed to be negative 3. There it is. All right, and there's my y value of 5. Nice. That looks good. Nice. I want to figure out this negative 3, but I want to prove it. I don't want to let the graph do it. I got to let the work do it. Where can I put this 2 to find it? With all the x's, right? Plug it back in. We've got g. Now, I don't want to say f again. This is g of something. Now, g of x gives me a spot to put whatever x I want. I have a very specific one in mind, and it's this 2 right there. That one goes in. So wherever there's an x, I'm going to replace it with parentheses. And look, that leading to that a, that went on the outside. Like the only thing I'm squaring is x. The 2 doesn't get squared. Not this 2, right? I'm just going to square whatever that x is. In goes that right there. So this is a 2 right there. This is a 2 right there. Okay. And when we're just simplifying, we're going down. Anything inside a grouping symbol first, then exponents or radicals, then multiplication, division, then addition, subtraction. Nothing inside of parentheses to do. They're just numbers. Okay. Now I take care of the exponents. The only thing being squared is this 2. This one comes down. 2 squared, this one. Okay. Parentheses if you want. Exponents. Now multiplication and division. 2 times 4. 8. Minus 8 times 2. So negative 8 times positive 2. Different sign, so the result's negative. 8 times 2? 16. Just so you know, this number is always double this one. This number is always double. Always will be. And then, okay, this multiplication division done, and then we subtract 8 minus 16, negative 8, plus 5, negative 2. And that's it. That's good old standard form. 2 things we can figure out: the y-intercept and the vertex. Obviously, the vertex is where all the work happens, and that's kind of the big thing that I want to make sure I check. Okay. I love it. Let's do a couple. I want to give you a chance to try it. Let's call it 3, 4, and 5. Find the vertex. Let's go a of x, b of x, and the y-intercept, c of x. So find the y-intercept and the vertex. X squared plus 6x minus 10. I don't know, let's go like 3x squared minus 18. It's the same thing as the one before it. I want it to be nice. 12x minus plus 8. And then like negative 2x squared minus, geez. I want it to be a little rough. 10x plus 11. 5 is a hard one. Give it a shot. Find the line intercept, find the vertex. And we'll be done. Let's call it. Okay. But try these out. I'm going to give you some practice for homework tomorrow to prepare for tomorrow night, just to make sure you've got it. And it'll include some of these trickier ones as well. So take like 5-ish minutes and try it. I'm going to wait a couple minutes. I'll do the first one so you can make sure you're on the right track. Wait a couple minutes, do the next one. Wait a couple minutes, do the next one. How's our boy doing there, Margaret? Happy? Comfy? Climbing? He was very active this morning too. I think he just likes the love and attention that he really just has not gotten much of lately. So I'm glad that you came so you could give him that love that he's so desperate. Huh?
You ever let him just run around?
So the carpet and his claws don't really make a good match. He gets stuck pretty easily. So no, not usually.
You ever take him in the grass?
I haven't really taken him outside much, honestly, in the last year, really.
Does he stay here all the time?
Mhm. He's a desert animal. He can do just fine. Getting him to and from the house is a pain in the neck. So when we go remote, I'll still be here in school, so I'll be able to take care of him. And in the summer, I would definitely take him home, but even 2 weeks. I come in after a week, make sure his water's okay. He's got plenty of food, and he just sleeps, stays warm. He's a good boy. Hi, Miss Knapp. Pretty good. How are you? TJ, right there. Absolutely.
Mine has a couple missing fingers from claw fingers down.
Oh.
They're from a long time ago, but they don't wiggle.
No, they don't. They're not like.
Geckos?
Yeah. So I had 3 leopard geckos. Philip, Seymour, and Hoffman is what I named them. Yeah, one of them was kind of a runt. So the other 2 kind of picked on him, and he lost his tail, grew back. They're just mean. He's at least, it's got to be at least 4. This is my second full year having him, but I got him 3 years ago, and he was already at least 1 or 2. So
Like 10 years?
at the most, yeah. He's got no predators here, so he should last a while. Because he is lazy when it comes to hunting. Like if I put live crickets in there, they would just like crawl all over him, and yeah. Mealworms, but those turn to beetles. If you get live ones, they'll change and become beetles. So then you have to like pick them out. Grapes, nice. They're super awesome, bearded dragons. They're really chill. Huh?
They're weirdly cuddly.
They're super cuddly. Yeah. Miss Neff, you want to see a bearded dragon? Look on her chest. That's our class pet. That's Squishy. But his full given name is embroidered on that piece of wood that Troy's walking by there. Liz Khalifa.
I have a pet turtle.
Nice.
That's it. I wanted that too. But I'm also freaked out by the sounds. I also love them. Wait, what's the name?
Along that piece of wood behind the pencil sharpeners, Liz Khalifa. Top of his head. Yeah, or down his back, under his chin. He's happy. He's a good boy, yeah. It's from the stand. Yeah. Okay, no worries. Yeah, so I sent him with a student for spring break last year, not knowing that we would never be back. And so his mom went crazy and bought like $100 worth of stuff for the tank, which is awesome, including the sand. So he used to have like the felt, piece of felt in there. You let students take it home? Absolutely. I trust my students. Sometimes they care for it even more. They love them even more, and they spend more time with them than I would because, you know, I'm around them all the time. You guys not as much. So. All right, let's see how we did. Let's at least do the first one. Let's switch colors though. Y equals, let's go, let's see how these do. Y, ooh, that's nice. Y intercept 0, -10. Vertex is gonna take some work. So that's what I'm gonna do. -b over 2. So A is 1, B is 6, and C is -10. So -6 over 2 times 1, so -6 over 2, which is -3. So I know that the y value, the x value of the vertex has to be right there. And so it's really all about remembering this. If you can remember this part, the rest of it just kind of takes care of itself. Calculators, now I'm telling you, you don't have to do this stuff by hand like we've been doing. All right, well, not A of -3. Really, all I want to see is you writing this step and then the answer. And that can be just as simple as going to a calculator and typing in exactly what I just wrote. Make it all go away. -3 squared plus 6 times -3 minus 10. -19. Why? Because 9 minus 18 minus 10 is -9. All right? This number always twice that one. So that -3 part came from up here. -b over 2a. That is our magical shortcut to the vertex. Okay? A lot of math happening in the background to get us to that point, but we don't need to know the background stuff. We just need the nice little shortcut. And that's it. -b over 2a. That's always the x value of the vertex. Yep. And I'm just going to graph it. I just want to make sure I got it right. I love Desmos. If you don't have a graphing calculator, you need this app on your phone. Desmos, by far the best calculator graphing tool, I think. Way down here, there it is. -3, -19. There's my y-intercept, 0, -10. It just works, man. I love it. It's so nice. Because once you get it, it's just done. You know exactly what you need to do. Switch colors for this one, so you know where one stops, the other one starts. 8, whatever that last number is. Vertex, I don't know until I do some work. My work always kind of starts with A, B, and C. I picked nice numbers again for this one so that the vertex worked out nicely. And I'll do that most of the time. Most of the numbers will work out. But sometimes they might not. That's okay. You got a calculator to back it up. I'm just going to plug it in. B of whatever that number was, 2. So wherever there's an X, now suddenly there's a 2. All right, so 2 goes right there and right there. And I'll see what I get. If you're doing it kind of by hand, you take your time, you just do the 2 squared, then multiplication, addition, subtraction. But I don't need it, honestly. Go like this. Just do that. Show the substitution. Gotta happen first. I gotta make sure that whatever you're kind of showing me, you know, how to do to figure out the y values, that it's going to come from you plugging that number back into the function. Magic, there it is. And a y-intercept to go with it. There's my vertex 2, -4. There's a y-intercept 0. So honestly, whatever's boxed in is what I want to see. Anything outside the boxes is just extra, I think. Obviously, the answers. These, obviously, I want to see that. But like writing down what A, B, and C are, that's up to you. Maybe you don't have to. That's fine. You know, I don't have to see every little step of arithmetic too. This is Algebra 2, not 7th grade math. So, you know, I just want to see the substitution and let the calculator give us that final answer. I'm cool with that. Especially with something like number 5, where the numbers aren't so nice. I'll switch colors again. Excuse me. Y-intercept and 11. You don't have to write 0, comma. You can just write the number. That's fine. I know what you mean if you say y-intercept. That's good. Vertex, I don't know until I do some work. That's a point. So I come over here. Negative b over 2a. I mean, I like to say, okay, a equals b equals c equals, so I don't mess it up. A is -2, b is -10, c is 11. So negative b, the opposite of -10 is positive 10. Just like the opposite of -12 was positive 12 up here. And then -2 times -2, right? No, positive 2, sorry. 2a. 2a, there we go. So 10 over -4. 4 doesn't go evenly into 10, so I don't have a lot of options here. I just hope there's a nice decimal, maybe. Oh, okay, nice. That's okay. -2.5, I can use that. Okay. If you wanted to simplify that fraction and call it -5/2, that's cool too. But if there's a decimal and you want to use that, I'm good with that. I like that. -2.5. Okay. Now the y value that goes with it, I've got to plug it back in. So C of -2.5. Okay, so -2 times. -10 times. All right, and right in here goes that -2.5, and here's why you shouldn't do this by hand. These kind of numbers happen all the time, and the last thing I want is for you to be taking like -2.5 and trying to square it, and taking -10 times -2.5 and doing all of that work. Just show me the substitution and give me the answer. 23.5. 23.5. Boxed in. Stop right there. I'm cool with that. Box that. That's the work I want to see. And I'm going to make sure that I'm not wrong. Let's type it in. -2x squared minus 10x plus 11. What do we want? -2.5, 23.5. Yeah. Looks good. It just works. Super nice. And there you go. 2.2. Done. Nice and quick, nice and easy. Really big takeaways, 2 things, right? C is your y-intercept, and then -b over 2a for the x part of your vertex, and then plug it back in. All good? Bam, 50 minutes like that. We got like 45 seconds. You guys are good. I'm going to turn this off. Thank you guys for watching at home. I will have a 2.2 homework, probably out later today that you can just get started, but it'll be your work for tomorrow. That we will check Wednesday, whether here or at home, depending on what happens. Okay. Then we'll do 2.3. We'll just keep rolling. I want to at least get that far before we get to Thanksgiving. That's the really big stuff, is 2.1, 2.2, 2.3. We've got that. I think it's going to take us 2 days to do 2.3. So we'll see. This is more work than we've been used to. But there you go. Have a good day, and I will see you guys next time, whenever that happens to be. I want to do these same problems again.